What is up, guys? Paradoxio here. Welcome back to a brand new video, everybody. Today we are going to be talking about a rather unusual topic that we don't really get into much on this channel, and that is trigonometry, let alone mathematics in general. Basically, what we are going to be doing in today's video is we are going to be making our own trigonometric functions, which there are 6 of them: sine, cosine, tangent, secant, cosecant, cotangent. Now, if you are a trig student, you will definitely recognize all 6 of those functions, and you'll probably recognize on how hard they were to deal with in trigonometry. I definitely had a hard time. But today we are going to be learning how to implement those in Python. Now, if you are a geometry student, you may only recognize sine, cosine, and tangent, because geometry doesn't really get much into secant, cosecant, and cotangent too much. But either way, we are going to be discussing how we can calculate all of those functions with a simple Python script. Now, before we get into that, we need to get into how sine and cosine are actually calculated. Now, if you ever wondered how they are calculated, you may have heard the phrase Taylor expansion be brought up, even if it was just a Google search or if you were sitting in class and asked your teacher how sine and cosine are calculated. It all goes down to the Taylor series or the Taylor expansion. Now, what the Taylor expansion or series, or whatever you'd like to call it, is a series of polynomials added and subtracted to each other in an alternating pattern all the way into infinity. Now, basically, each piece of this formula is considered a term, and the more terms you have in the formula, the more accurate your sine or cosine approximation will be. So basically what we are going to be doing is calculating sine and cosine first, and the last 4 trigonometric functions can be calculated using the sine and cosine functions due to the trigonometric identities that exist, and also by similar triangles. Now, basically the image I just put up on the screen right now is the formula for the Taylor expansion for sine of x and cosine of x. That is what the polynomial actually looks like, and if you were to, for say, pop that into Desmos or a graphing calculator, the graph may resemble the same graph of sine or cosine of x. But anyways, before we actually get into the trigonometric functions, we do need to make one other function called the factorial. Now, if you don't know what a factorial is, a factorial of a number is basically the number multiplied by one less of itself until it reaches 1. So for example, the factorial of 4 will be equal to 4 times 3 times 2 times 1, which will equal 24. The factorial of 3 will be 3 times 2 times 1, which will be 6. And yeah, so we are going to make a factorial function first, and it's not very hard. It just deals with a for loop with a range method. So we are going to go ahead and create our factorial method, and I'm just going to call it fact. And inside here, I'm going to pass in constant, which needs to be an integer because we can't take the factorial of a decimal. For that, you will need to use something called a gamma method, which we are not going to get into in today's video, but we will in the near future, hopefully. But what this is going to do is going to return a integer, so I'm going to make it a little arrow and then int right here and then indent. Now, this here isn't really important, but it's good practice when programming because it makes readability pretty easy, and it's easy to see what the function actually returns. But for factorial, what we're going to do is we're going to create a variable called fact, and we're going to set it equal to 1. And then we are going to make a for loop here, and this is going to be for num in range. First thing we're going to pass in is 2, and then a comma. And then we are going to pass in constant, or whatever we named the argument up here, and we're going to add 1 to it, which is why it's important that this is a integer and not a string or whatever. After that, we can go ahead and indent, and we are going to type in fact times equals num. And after that, we are going to indent again, hit the back key, and then type in return fact. And that's it. So if I were to go ahead and type in print fact and then 4, remember the factorial of 4 is 24 because 4 times 3 times 2 times 1 is 24. So if we go ahead and run this, as you can see, we get 24 at the bottom. Let's do 3, which should return 6. And it does. So our factorial function works and it prints out the correct results. Now let's go ahead and write the sine function. Now, if you recall back to the image I displayed on the screen earlier, the sine function is defined by x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and then so on until infinity. So what we are going to do is we're going to create our sine function, and we're going to call it sine. And we are going to pass in x, which is going to be a float. And then this is going to return a float. And let me just fix that slight error I made. There we go. Now what we are going to do is we are going to set x equal to math.radians x. Now I actually need to import math for this unless you want to make your own radians function. I'm not really going to get into that in today's video, but how to actually calculate radians, it's just degrees times pi divided by 180, I believe, or it might be the other way around. But we are just going to import math for this so we don't have to write any more of these methods. But anyways, we're going to convert this to radians by writing that simple line right there. And after that, we are going to create a variable here called result, which is going to be equal to 0. And then we're going to create another variable here called sine, which is equal to 1. Keep in mind this isn't sine as in sine of x. This is sine as in like a positive or negative sign. So don't get that confused. And after that, we're going to create another for loop. So for in range. And then we are going to pass in a number, which is 10. Now what this really means is this will go on until the amount of terms reaches 10. You can have 15 terms or 20 terms or 50 terms. Keep in mind, the more terms, the more accurate. However, the maximum amount of terms that Python will allow you to do with sine and cosine is 85. So if you put in 86 terms, it will just throw you in error. So the maximum you can do is 85, but for now I'm going to leave it as 10. And after that, we're going to go ahead and indent, and then we're going to create another variable here called term, and we're going to set it equal to x, and then another set of parentheses, 2 times n plus 1. And then we're going to divide all of that by fact, and then 2 times n plus 1. And that's it. After that, we can go ahead and type in result plus equals sine times term. And then we are going to alternate sine between negative and positive, which is just going to be like this, sine times equals -1. Because eventually, when it becomes negative, a negative times a negative will be a positive, and then a positive times a negative will be a negative, and it will just keep alternating that way. And after that, we can go ahead and backspace out of this, and we can go ahead and type in return. And this part is optional, but we can round it by using the round method that Python provides you. Sorry. And we're going to pass in results, and for me, I like to have 10 digits. And yeah, so that is it for our sine function. Now, if I were to go ahead and print sine of 90, now if you have memorized the unit circle, you would know that sine 90 degrees or sine pi over 2 is equal to 1. So if I go ahead and go to Google here, I will check that sine 90, and I'm going to actually set it to degrees, and then sine 90. And as you can see, sine of 90 degrees is equal to 1. So we got that correct. If I go ahead and run this code, as you can see, it prints out 1.0. Now, if I were to put this in 5 terms instead of 10, as you can see, it gets less accurate, but not by a lot. If I were to do 2 terms instead, then it gets really, really inaccurate. So it's best to keep the terms somewhere reasonable, because really what you're doing with this is approximating, because our computers can't just keep doing this into infinity. It has to stop at a certain point. So we approximate it with a set amount of terms. So really, this isn't the exact answer. This is just a approximated answer that is really, really close to what you want. So let's go ahead and try sine of 45 degrees. Now, if you remember, sine of 45 is like 0.707, I think. Yeah, 0.707. So if I go ahead and print sine of 45, we get 0.7071067,812, which is a little different than what Google says, because Google has a more powerful approximating system, I guess, if that's what you want to call it. So Google's answer will be different, but what really matters anyways when you're actually calculating something like distance or like the side of a triangle or whatever, it really only matters like the first 2 digits, or I'm sorry, the like hundredths place or the thousandths place. That's really all that matters. So really, as long as the first 3 digits, or first 4 digits actually, I should say, are correct, then really you will be fine. The rest doesn't matter too much. But anyways, as you can see, this approximates it pretty accurate. Now, of course, if I were to increase the value in range, it'll be a little bit more accurate than before. But anyways, let's go ahead and create our cosine function. Now, if you remember the cosine function, it also uses the Taylor series, and it's just a little bit different. So really, we can just go ahead and copy and paste this. Another reason we're able to copy and paste this is because cosine complements sine. They are complementary functions to each other. And they're a little different, but no worries, they're not by a lot. The big difference is we don't need +1 here. And that's it. That's literally it. Okay, or wait, whoops, I did that in the wrong function. Whoops. Sorry guys, but literally, cosine just does not need the +1. And we also want to change this to cosine. And if I go ahead and print cosine, let's see, I know cosine 180 is -1. So if we do cosine 180, we should get -1, in which we do. Although, as you can see, it's a little bit of an error right here, but that doesn't matter because we're just interested in -1.0. Now, a pretty strange glitch I noticed is if I were to put 360 here. Now, I don't know if it's going to do it with the cosine function, but it does with the sine function. Okay, so that's actually supposed to be 1, but like I said, it's all about how many terms you have. But if I were to go ahead and use sine here of 360 instead of cosine, we get -0.0, but if we were to round that, it'll just end up being 0. So actually, let me add 85 terms here. That will change it to 0.0, but if you keep the terms low, it'll eventually just be -0, which is not what you want. Well, actually, it may not do it here. Or you'll also get something like this, which probably don't want, but that's just E notation. It's really it is the correct answer in terms of how you approximate it, but sometimes Python will output it in E notation, depending on how many zeros it is to the left of the decimal. So I'm gonna go ahead and add 15 terms here. 20. Let's do 20. Alright, so 20 gets a 0.0. So it looks like for sine, you'd want to keep it at 20 if you want it to be as accurate as possible. But I want to leave it for 10 for now because we are going to do something with these here right now. So let's say we want the user who's using these methods to have control on how accurate their sine or cosine approximation is. Well, what we can do is add a threshold argument. So that we're just going to type in threshold, which is going to be an integer, and we're also going to set it to 10 by default. So I'm going to copy and paste that here, and we're going to replace the argument in range with threshold. So by default, if we leave threshold blank, or if we don't provide an argument for threshold, it'll just leave it as 10 terms. But if we do add our own terms, it'll approximate it to that amount of terms as well. So I'm going to go ahead and type in print sine of 45. If you remember, this is the answer we get out. Now let's say I want to give a threshold of 15. I run it again. We still get the same answer, but let's see what else we get. 85. Alright, so maybe 45 degrees isn't the best one to use. Let's just do 90. And change this to 5 terms. As you can see, at 5 terms, it's a little less accurate. 2 terms, it's going to be really inaccurate at 0.92. But as we add more terms, it gets more and more accurate as the terms add up. So at 10 terms, it's pretty much good enough for 90 degrees. You get exactly 1.0. So basically what I did here is I gave it to where I given it control to how many terms you can have with the function. Keep in mind though, the maximum amount of terms you can have is 85, because if we put 86, we get an overflow error, which basically means the integer is too large to convert to a float. So yeah, that is how we can have control over our threshold. Now that part is optional. You can keep it as 10 terms if you want. But if you want to give your user control on how many terms they want their approximation to have, you can add a threshold argument. Now let's go ahead and calculate tangent. Now this is going to be really easy, because unlike sine and cosine, tangent does have its own Taylor series. However, we don't need to use it because there's an easier way we can calculate tangent. Now, if you remember in geometry or in trig, tangent is the same as sine divided by cosine of x. So that is the rule by similar triangles. Tangent of x over 1 is equal to sine of x over cosine of x. So I'm going to give this a float value, and then threshold is going to be an integer, and we're going to set it equal to 10, and then we are going to make it a floating point value. And inside here, we are just going to type in return sine of x, and we're going to leave this as threshold, and then we are going to divide that by cosine x, and then threshold, and that's it. Now if we go ahead and go to Google real quick and go to tangent 90, change it to degrees. Tangent 90. We get an error because the number is too big. Actually, let's do tangent 45. Alright, we get 1. So the tangent of 45 degrees is 1. So I'm going to go ahead and print tangent 45. I'm not going to really do anything with the threshold yet, but we get 1.0 because 10 terms is enough to get 1.0 for the tangent of 45. Now, if I put tangent 90, the reason why it says error is because you can't divide by 0. because the cosine of 90 is 0. And since the formula for tangent is sine of x divided by cosine of x, really you're getting sine of 90, which is 1, divided by cosine of 90, which is 0, which is 1 divided by 0, which is an error because, as you guys know, we cannot divide by 0. So that is why a tangent of 90 degrees is a 0 division error. But anyways, let's actually go ahead and do a couple if statements, just in case the user tries to use 90 degrees as an argument. So if x is equal to 90, and there's also another one which is 270. So or x is equal to 270 in degree. This is all degrees, by the way. We are going to type in return undefined. So now, if we were to go ahead and print tangent 90, as you can see, we get undefined, and 270, which should also return undefined. And this is because if we take the tangent of 270, it is also an error because the cosine of 270 is also 0. So they're both 0 division errors. Now let's go ahead and make our other 3 functions, in which we can really just copy and paste this. So we're going to copy and paste. And this one is going to be cotangent, or actually we're going to make this secant. And then cosecant. And then we can just make this cotangent. Now, we're going to change this to tangent here. Now, the cotangent formula is really just 1 divided by tangent, or 1 over tangent. For cosecant, it is 1 divided by sine. So we are going to change that to sine, and then change this to 1. And then the formula for secant is going to be 1 over cosine. So we are going to change this here to 1, and that's really it. Now we need to change the if statements for the angles because they're all different. Secant is the same as the secant values that return undefined are the same, so we can just leave the secant one alone. But for cosecant, it is going to be 180 or 360. And for cotangent, it's a little different because the only way cotangent returns undefined is if the argument is 0, because tangent returns 0 if the argument is 0, and since the formula for cotangent is 1 over tangent of x, if x ever happens to be 0, then it's just 1 over 0, which is obviously a 0 division error. And yeah, so that is it for our other trigonometric functions. Now, I'm not going to test these other ones out, or maybe I'll test one. Let's test secant. So let's say I want to find the secant of 45. Oh, whoops, secant 45. I'm going to go to Google real quick. So secant is, actually, let's go to Desmos. On 45 degrees to radians. Alright, so secant. Wait a minute. 45 pi divided by 180. Alright. So we should get 1.41. So if I go ahead and print this, yep, we get 1.41. Now, granted, it is a little less. No, this one's pretty accurate to an extent. But anyways, as you can see, our secant function works. And as long as you coded these with the correct formula and the correct variable or the correct values for x that return undefined, then your function will work perfectly. So yeah, that is how we can implement our own trigonometric functions in Python. Yeah, so that is it for this video. Thank you guys so much for watching. If you have enjoyed this video, be sure to hit that subscribe button, hit that like button, and comment what you guys would like to see next time. Would you like to see more math and coding related videos, or would you like to see more coding videos about game development or for Discord bots? Tell me guys what you would like to see. Let me know in the comment section. If you want to hang out with me or over 500 other people, join my Discord server. We also have help forums with coding if you guys ever need assistance with your code. So if you ever need help or you just want to hang out with me and a bunch of other people, go ahead and join my Discord server. The link will be down in the description. Thank you guys so much for watching. I hope you enjoyed the video. It was pretty fun implementing our own trigonometric functions for our program here. So, if you guys had fun coding with me, hit the subscribe button, and I'll see you guys next time. Bye-bye.